What's up guys, how are you doing? Today we're gonna learn the new and one of the fundamental parts of the math is the trigonometric identities.
Before we start, you have to read all instructions carefully. You have to solve, be active and solve all exercises before I will do it. And the most necessary thing is bring with you to our lesson your good mood and just begin. Before we start, and you have to know what is the trigonometric identities. What is the trigonometric identities? Trigonometric identities is the trigonometric function which involves the trigonometric function and holds true all variables and holds true all the variables of our given function. Okay, but now I want to show you where did we get all the main functions, main formulas in the trigonometric. As you know, the main formula in the trigonometric function is the sine x squared plus cosine x squared equals to 1. And here we have to prove where did we get 1? Why sine x squared and cosine x squared equals to 1? And that is called, our proving this is called trigonometric identities. And for proving, just draw the unit circle in the plane. For example, here, just draw the plane 1, 1, minus 1. And our circle here. Our circle will look like that. And here, the right triangle can help us to understand where did we get this formula. And here, if we just draw the radius, just sign it with the R, and here just sign this length with the A, this length with the B. And as you know from the previous lessons, the sine, cosine is the angles, and here you can just sign the X. And if we consider it from the sine, we know that, you know from the previous lesson that the sine is equals to opposite lengths of the triangle divided by the hypotenuse. And here we just can write sine x is equals to b over, and as you know this is a unit circle, so that is 1, our radius will equals to 1 b. And what about cosine? And here if we consider it from the cosine x, the cosine x is equals to for the adjacent length divided by the hypotenuse. And here we can write cosine x equals to a over 1. Here we get a. And from the, you know, just remember the Pythagorean theorem, and here we can write c squared is equals to a squared plus b squared. We know that the c is the hypotenuse of our right triangle, and as you can see here, you know that the radius is the 1, and the hypotenuse of this triangle is equals to 1. So that is why the square of 1 will equal to 1, and square of a added by square just plus square root of b. And from here we know that the sine x is equals to b. Here we can write sine x, and here we have square, so that is why here we just write the square too, and here the cosine x. And from this I think we understand where did we get this formula. And we know the second part is we know that Осы кесіп алу керек.
Это почему сообщение кольцо?
And here, what about the tangent and cotangent? As you know, the tangent is the equals to for the tangent angle is equals to opposite length divided by the adjacent length. And here, as you know, we just earlier we draw the unit circle, and here we draw like that. Here was the 1A and the B, and we consider this angle. From this angle, our tangent will equals to the opposite length divided by adjacent length. And we know that from the previous example that our B was equals to sine x, that our A was equals to cosine x. So that is why we can write it sine x divided by cosine x. And here we proved where did you get the formula of the tangent x is equals to sine x over cosine x. But what about cotangent? We know that cotangent x is equals to the adjacent length of the triangle divided by the opposite length of the triangle. So we can write the cotangent x equals to just A divided by B. This is the adjacent length, and this is the opposite length for our angle. And here we know that cosine x divided by sine x. And here we proved, I think we understand where did we get where did we get these formulas. And if we get it, just we can consolidate our new knowledge by the solving some new examples. And now let's solve the new example. Here you can see the cosine x in the fourth degree minus sine x 4 degree and divided by the cosine x squared is equals to 1 minus tangent x squared. And we have to prove what is the trigonometric identities. As I said, we have to prove one side that the second side is the equals to another. And here just we know that we can work with left side of this equation, so just work with the left side of this trig equation, of the trig identities. Here, as we know from this, we can. Do you remember this kind of formula? Here minus, and then by this formula we can rewrite this one like cosine squared plus sine x squared times cosine x squared minus sine x squared divided by here cosine x squared. And as we said, we work only with the left side of our trig identities. And here we know that one is equals to 1. And what about that is 1? What about that one? We can write it here. Cosine square x minus sine square x divided by cosine square x. And this kind of example we can rewrite like by the factoring it, cosine x squared divided by cosine x squared minus sine x squared divided by cosine x squared. Here, we know that this part will give us the 1, and from the previous example, this part gives us the tangent x squared. And here we can write just 1 minus tangent x squared. And this is our left side, and this is our right side. And here we proved we get from this one, second, the right the right side of our trigonometric identities. And here, let's consider the second example. Here we can see that the sin x and cosine x and the square just as in the beginning, as in the previous example, we have to work only with the one side of our equation. And here, as you can see, we can work. It will be pretty easy to work with the left side of our equation, and here by the formula which we passed in the 7th grade, we can write the that one will give us sin x squared plus 2 sin x cosine x plus cosine x squared. By this formula, I'm pretty sure that you know this kind of formula. And by this one, just you can write it. And here we see that we can write it the sin x and cosine x. Just we know that the sum of the sin x squared and cosine x squared will give us the 1, so that is why we can write it the 1 plus 2 sin x cosine x. And here you can be the rest of this kind of picture. Here you can see that our left side of equations now are same like as the right side of our equation, and that's we just proved it. We showed that we showed how the trigonometric identities work. And now the second part of our lesson is the proving of trigonometric identities in the changing of the function of like the cosine x for sin x and sin x for cosine x and etc. And here we can consider it by the example as you can see here, and we just we have to prove that this our equation will equals to for the cosine. And as you know, we can just open the brackets by this kind of formula, the sine, and just here you can see the x plus y equals to sine x times cosine y and plus cosine x times sine y. And here we can just open the brackets with, as I said earlier, with this kind of formula, sine, the p of 2, we know that this is in 90 degrees, and here just cosine theta just plus sine theta cosine 90 degrees. And as you can see here, this one, the sine in the 90 degrees will give us the 1, and cosine the 90 degrees will give us the 0. And as you know, this part of our example will be 0, and here 1 times cosine theta gave us just cosine. So here we just proved this kind of example, and for the make the easy the solving of your examples, you can just memorize this kind of table. By this table you can just learn how it will change in the like p over 2 just plus theta plus the angle. And but I want to give you the hack to solve easily without any memorizing any formula, without memorizing any tables. I want to give you one easy hack. And here you can just see, if just move to the next example, we can solve this example by, and here you can see sine 2 pi plus pi over 3, and here we know just I want to know, I want that, you know, here we can consider it that with the p over pi over 2, if the coefficient before pi over 2, we can more precisely, we can say 90 degrees will be the even number, our function won't change. But if the coefficient between before our degree in the 90 degrees will the odd, our function will change. Here, you know, the 2 pi, but in the if we consider it from the pi over 2, we know that the coefficient between here will be for like pi is equals to pi over 2 times 2 here, and just 2 here, and here 2 4 times pi over 4 pi over 2. And from this we know that the coefficient before the pi over 2 is the even number, so that is why our function won't change. And here we can just write sine. And what about the positive or negative side of our equation? We easily can know it by the drawing it on the quadrants, by the dividing on the quadrants. As you know, just for the sine, for this kind of example, for this kind of function, for the sine, the first and second quadrants are always positive, and here you can see that 2 pi, we know that 2 pi is placed over here, and just over here, yeah, 0 pi over 2 pi, and 3 pi over 2, and 2 pi, and plus our angle pi over 3 will be approximately here, and just we move the heat for here, and here in this quadrant our sign is the positive, so that is why this kind of our function will be positive. And here we just write here the, as you know, our function won't change, and sine pi over 4 with the positive sign. And as you know, the value of it will be just in the root of 3 over 2. Here you can clearly see that this length of A and B, just with help of their tangent, they make the one whole thing, more precisely the hypotenuse. And in the real life are the very same, are the very similar to here. We have to be together, we have to be in unity with others, and it really can help to achieve our goals very easily. As you can see here, that the A and B just make one whole, our hypotenuse. So that is why don't lose your unity and always be together and work on them.